With the usage of microservices in application modernization, we have seen both the advantages and disadvantages of maintaining such software development styles. In this talk, our speaker will explore how we can use Modular Monolithic and take advantage of it. He is currently the Java User Group leader of Java User Group Philippines, an author for Fujay Community, and an open source contributor. Everyone, give it up for Senior Technical Specialist at IBM CIC Philippines, Mr. Reynaldo John Tristan Mahine Jr.
Hello everybody and welcome to my session for Modular Monolithic in Practice, and we will explore it through Java. Okay, I'm gonna share my screen now. Okay, I think that was fast. So yeah, welcome again for the SoftCon 2023, and we will be dealing with the Modular Monolithic in a pragmatic approach. So this time we will explore it via theoretical and practical. Okay, next slide. So I'm gonna introduce myself. So I'm Tristan Mahinay. You can call me Tristan. I am a senior technical specialist at IBM. I'm also the Java User Group leader for the Java User Group Philippines. I'm also handling internally at IBM the Java capability, and also an open source contributor focusing on Quarkus, a microservice and Kubernetes framework. And here is my email and my social if you want to connect and ask some questions about technicals. Introduction. So in this introduction, I will be having the fundamentals first about modular monolithic. So before we have a deep dive on the modular monolithic on what it is, we will try to understand first what are the problems, why we want to use this, and then when will we be using this, and also how we will be using this. Okay, so for the first slide, before I show the graph, so we will be dealing now with complexity. So yeah, complexity in technical terms is how is your software related to each other, how it is, how one change can affect the other. So that is part of some of the complexity, and what are the effects of use of a complex structure in your code. Okay, then the next one will be our first graph. Okay, so yeah, the graph is kind of, I don't know if you are familiar with the terms, but I will be explaining this one by one. So in the x-axis, it will be the granularity, meaning how the services are decomposed to each other, starting from from the big ball of mud where your services are very tight to each other, and then up to the distributed big ball of mud where it is so shallow now that your logic inside of your services is very obvious, and it lack a complexity in dealing with the integrating to other subsystems of your software. And then on the y-axis will be the complexity on how hard it is now to maintain it. So in the middle is a modularization. That is the one we will try to explore until the last session. So firstly, the green line, which is the local complexity. So if you deal with the local complexity is the one that is the complexity inside of your application without interacting first to other services. So how is your services now is decomposed to each other? Like, is it your services are doing the right thing inside your application, or it is just that you just inject it and have a bad A solution when you develop your application. And then the next one is now the global complexity. The global complexity now includes on how you interact now remotely to other services. So this one is the worst case of this one is have too many global calls, or it is called your too many remote calls. Like you have too many REST API calls in your application, even though some of that REST APIs can be achieved within your application. So the two worst cases from the first x-axis will the big ball of mud, which is you lack cohesion here. Your services here don't know each other, but they are related in reality. And then the other one is the distributed big ball of mud, which is also called a failed microservice. Your microservice now is calling each other in a acyclic format, meaning they are calling in a never-ending loop. So that's why some of the microservices calling each other have this very high latency, because they're just calling each other in a round robin format. And then the one that is the our target will be the modularization. That is, we are we are balancing the global complexity, the remote calls, and also have a higher interconnection with our services in our single application. So yeah, just remember the two complexities, and I think you have already encountered this in your professional life. I think that the term is just very technical. Okay, so the next one will be, so over optimization of local complexity. Your services, you are optimizing very much your code in your application, even if it doesn't need to be optimized that much. It is also called over engineering inside your application. It is just like, I think I will need this in the future, so I will put this in my code. So that's why some of the applications is called it converted to a big ball of mud. So it is just inside one of your application, no remote calls yet. Okay, the next one, over optimization of global complexity. That's why there's called a distributed big ball of mud. So I want to create so many microservices because maybe in the future I will call this one and that, and then the requirement of the client suddenly scrap all of that. So yeah, you have now a distributed big ball of mud. You have a technical debt, and the succeeding task that you will have is to clean that all in your work. Okay, next. So the problem, so the anti-pattern. So I've discussed earlier the anti-patterns, the one with the big ball of mud and then the distributed big ball of mud. So let's try to have a more detailed description of both of them. Okay, anti-patterns first. Big ball of mud, it's a failed monolithic. Your single application has suddenly failed in a because of the developer has put some band-aid solutions that is keeping it forever, and then it became a legacy one already. So the next developers, so the next developers also do that, and so on and so forth. And then the other one is high coupling. So high coupling meaning it doesn't need to interact with that, but since you have a band-aid solution without any purpose, your services now are interacting with each other, even though it doesn't need that. And then low cohesion, which is the internal calls. So meaning internal calls is just a method call, like you are calling one class to another, but your cohesiveness has since I said earlier that it has no purpose, your cohesiveness now is very low. You are calling a class or a function that is not related to that, and then it is just it is a a result of a, sometimes it called them a god class. So you are injecting so many functions method in one class, and then and later on you are wishing that some developer will fix it because you are now in a different project. And then the next one is high cost of change. So the high cost of change in technical terms in architecture is called connascence. So connascence is how the methods are related to each other. So if you remember, like if you we go deeper, so are you aware that there's an impact if you have too many parameters. If you have a naming convention that is not very developer friendly, or your method is dependent to other methods in such a way that, for example, this one will not be executed before this one, but if you have too many like that methods, then your connaissance will be high also, and it will be subject to high cost of change. In the future, we'll have too many technical depths in your Jira board. Next is a distributed big ball of mud. So this is a failed microservice. This is just a monolithic, but in a using a distributed in a distributed fashion. It is calling remotely too many services. So imagine a microservices calling too many microservices, and that under that microservices is calling another microservices. So that's just monolithic, but just it is just distributed because the ownership of microservices is in different teams, right? So it will be high, it will be also a high coupling and the low cohesion, but now it is called in a remote call. So remote calls can be SOAP, can be REST, can be RPC, grpc. So that's one of the methods of using remote calls. And then the high cost of change. So similar to the big ball of mud, the connaissance or the high cost of change is also very high on this one, because it is now calling too many APIs that is not part anymore of its domain. So we'll talk about domain later and how it will help us to solve these anti-patterns. Big ball of mud. So this is big ball of mud. So you have a component. So component here is just a class under your module or your package. In C Sharp, it's called namespace. In Java, it's called module. And then the method calls of each of the classes is like an ending loop. It's calling back and forth without any purpose, and then it's causing you a very high cost of change in the future. And then as you can see, it is just in one under deployment unit, meaning that the monolithic application will be deployed in just one, for example, one jar. So that's the meaning of the deployment unit. And then the purple one, yeah, the internal invocation or so-called the internal calls. Okay. So next one is distributed big ball of mud. So it is similar to the one that I showed earlier, the previous slide, but now the deployment unit is different because you can have a services deployed to different platforms or different by different teams, and then it's still the same. It is called now the external invocation, the one with the purple arrow. So it will be now using, for example, the famous REST API. And then as you can see, without any purpose, they are calling each other in an ending loop. And then, yeah, just the same, your connaissance will be very high, and will be a technical depth in the future. Okay. So let's have a tweet from Felix Mueller. So it is hard to build a well modularized monolith. So we decided to create many bad modularized microservice. Since because we can't handle a monolith well, we created microservice, but they didn't know that it is still the same. You will just create a application that is also like a monolith, but just called distributed. So many of the, I think, of the organizations, developers are subject or are guilty to this, because if they don't want to handle any more monolith because it's a very legacy, it's a very not good. The code is not well documented. The code interact the services of the code is not anymore understandable. So they decided to decompose it already to microservice. But it's still the same after a few months after they have this review of the application. It's still the same. It's like a monolithic after all. It's different because it's just using an API call. So cost of change. Let's see the cost of change. So I've said earlier, connaissance component need to change. The components need to change to maintain overall correctness of the application. So if you change one of your method, or if you change one of your REST APIs, how it is can impact the other application. So if it is very quick, very low, then your connaissance is good. It's low. And if it is not, it can impact many teams. Unfortunately, for microservices, it is evident. So there are techniques to avoid that, but we will not discuss this since we will focus on modularization. But there are techniques to avoid that. And but in the for the monolithic application, the yeah, that's why you are refactoring too many codes, because your connaissance is very high in your application. So let's try to see the graph. So as it's related to the first graph, but this now you will see that the y-axis is a cost of change, and for the big ball of mud and the distributed big ball of mud, the change is very high. And then our target is called modularization. The problem. So what are the cause of those two extreme cases? So I think some of it I've mentioned already. But let's see now. This is three these are the metrics that is causing those big ball of mud and distributed big ball of mud. First is low cohesion. So your modules or your packages, your classes inside your application is not that very cohesive. It's not relating to each other. That's why it's called injecting too many codes in your application. Even though if you rearrange it, your code, you can have a relationship with it. And then the next one, high coupling. So high coupling, they are very dependent to each other. So they're related to the cohesion. Your coupling is very high. So without a relationship, then you will just calling a function or a method, a class that is not related to your specific jurisdiction or domain. High connaissance. This is the one that if you code something, then you are not very keen on what you are doing. Like, I just name it like this. I just put parameters as many as I can. I don't consider any design patterns. And also, for example, if you have too many if in your method, I think the suggestion will be two if in one method. But if you have too many if, more than two, then that's applicable to be on high connaissance. And also, if it is very dependent on the execution of different methods, like it will be just called if this method is called, then it is susceptible to a high connaissance. So these three metrics, I call these metrics because this is also used for modularization. So these three metrics, if not solved immediately, then you will have the case of the big ball of mud and distributed big ball of mud. So what are we trying to solve? So let's try to explore now. how will we solve those extreme cases, and how we will have a high cohesion and low coupling and low connaissance. Functional cohesion. So we talk about cohesion, but now we must aim to a functional one, meaning your application, your services has a purpose to each other. It is related to each other. So they are now, if they are in one of your module or your package, then if we see this, that it really makes sense that they are in that particular package or module. So that's what you call functional cohesion. A system that is fit in our current environment. We don't want to create a system just because we want to do it, and then in the future, we just we will have a wishful thinking that in the future it will work. So we must also have a plan on our current environment. Plan to create an application in our current environment. So what makes sense in terms of what we have, the resource, the constraints, we must consider that. We must consider that in the present in creating that system. And then given the constraint that we have, what our priorities? So we have the constraint. There's no perfect system. So later on, I will show the characteristics of the modular monolithic and why it will make sense on some of the scenarios that we have when deploying an application. So go now to architectural thinking. So architectural thinking is not thinking about the best or the best technology that we will use in our system. So it will be the trade-off. So meaning, given the constraint, given the environment that I'm in, what should be my priority? What should be the technology that makes sense at the moment? And then yeah, later on we can have a refactoring of that. And the modularization is one part of that, since it will make sense if you refactor something in the future, then you have already established a potential system to do that. So some quotes that I have is from Mark Richards and Neil Ford: never shoot for the best architecture, but rather the least worst architecture. So just create a system that is simple enough given the environment that you are in now. And then there's no right or wrong answer when architecting or creating a system, that it is only trade-off. So if you prioritize some, for example, security, then you will trade off some of its parts, like being the performance of it, because having a secured application will reduce your performance. And then there is no sense in talking about the solution before we agree on the problem. So the problem must make sense first before we create a solution and implementation to create our system in our current environment. So when we create a service or just a maybe a new method in our system, let's try to reflect first if what is the problem first, why should we do this, and then talk about it to your respective businesses, because the requirements is the one that must be solved first before creating a system and implement it in your code. Next. So these are the books that you can read also to enhance your business domain and architectural thinking skills. They are very helpful to improve your knowledge on this um, different style of architecture. And then it will make sense when you are familiar with different kinds of architectures, and you can practice also if yeah, I think this will make sense most of the organizations, since this book are written by authors from an enterprise company, since most of us here are from enterprise. And I think also startup is good also. It covers also a how we think architecturally for startup applications. So next one is fundamentals. So we must understand first the fundamentals we before we do the complex ones, and then the hard part. So after you learn the fundamentals, after you learn the business domain, um, during the process you will have a hard part, and then yeah, maybe you can use this book for you to guide on how to solve those struggles during your development or your system creation. Okay, so solution is applying a pragmatic approach, an approach that is used in the industry, not a research based, not a theoretical one, but a solution that is already applied in the industry by some of the experts in the technical industry. So first, the very famous, the domain driven design. The domain driven design is a communication style so that your application will be much more closer to what the requirement of the business is. It's all about communicating the requirement, the the trade-offs to your respective organization, businesses, and then from that you can have a plan on how to implement your application. So from a communication, you will have a called a bounded context or a domain. So what I'm trying to solve here, for example, I will build an uh, financial services application, and then what are the bounded contexts for that? Some of it are called the payment, some of it are called credit and loans, some of it are called the savings account. So I think under the account. So that is one of the bounded context. So you are now from the communication, from communicating to the business, you are now trying to create a system on how will you implement those or the application as a domain, and that you can focus on the different domains within it. So from a bounded context, there's a tool called a strategic design. But strategic design is for people who are into more of a business side. So it's more of a theoretical. So we will focus on the other one called the tactical design. The tactical design is the one, what is the system that I will implement? What is that makes sense to the bounded context, the domain that I'm trying to solve? And what are the trade-offs that I will be considering with with a given constraint in my environment? So let's explore this. Okay. Okay, let's go to modularity. One of tactical design in domain driven. So what is a modular application? So we will answer this one by one by starting from a fundamentals. So what is a module? So a module is a logical grouping of your code that is based on a domain. So using a domain-driven design, you want to group your code inside your application based on the of its business perspective. So we will not just create like an MVC controller. I will put this because it is a controller here. I will create this because this is a view. I will create this because this is a service or a repository. So that is one of the way of common structure of your MVC. But this one, using domain-driven design, you will now group your code in such a way that it will make sense both on you and your functional requirement. So a sample is, yeah, that's one. That's the icon for the package, and then the equivalent that for Java or the related languages. So most of it are named like that, the domain of the organization, and then the specific domain, which is, for example, is employee. So, relationship of a bounded context and the module. So, let's go first to the single deployment unit, or called monolithic. So, bounded context, from a communication part. So, from my communication, you communicated already requirement. You transform it to a module, which is called now a domain. And then a module is part of a bounded context. So, a bounded context also can have many modules, if you will. And then that's also true for another bounded context and another module for that. So this type of work is like called a decomposition. There you are decomposing now the one communicated to you to a technical in a technical manner. So from a functional one, you will convert it to a technical in your code, so called module. And that's also evident for a distributed deployment unit called the microservice, if you will. It is the same. So, for example, since the deployment unit is different from each other, so one deployment unit can have already a one bounded context or one domain that you are trying to solve, and then the other one is the other one, like the first one can be a savings, the other one can be a credit. So you will have different microservice for that. So they are trying now to solve different domain perspective. So let's go now to um, so monolith, let's go back to monolith. So monolith, if you will, is also like a composition of modules. So when you say modularity, monolith also is composed of different kinds of module, such that it is just in a single deployment unit. So components are packaged in a single deployment unit. So some of the components here um, is called the module, and we erase first the domain. So it is just a component. Without domain, it is just a component that is in a one application, and they are that are in the services within that component or module are interconnected with each other. So that's why they are called internal calls within the application. So just like that, you have an internal invocation, one single deployment unit, and then module that are interacting with each other. So later on, we will be using this to back up the modular monolithic application. And then microservice, component interacting remotely, different processes, different platforms, and then are composed of services that are now independent of each other. So since you already created a different services in a different platform, it is makes sense that there the services that the one is created is independent to that the one created by the other microservice. So that's why there's different teams on both sides. If it is related, then most likely you will have a high coupling on that can cause distributed monolithic. So just like that, they are interacting with each other, but they are just independent since they are deployed in different platform. Okay. So we will have a comparison between a monolithic and microservice. So the other one is one artifact. Okay, so we can call this one jar or one just a one package, and then the other one separate artifact, different jars that are deployed um, to your environment or platform. And then since monolithic is just one application, it is considered too easy to refactor since you will just refactor on one application. You will not go to other repositories, fixing another code. Unlike the microservice, it is difficult because you will need to communicate now to the other teams because they are the one created that application. So you will need to understand first why the domain or the context of that application is like that before you fix something there. Else, you will have difficulties. And then method calls for the monolithic, it is very obvious. And then the network calls for the microservice, the APIs. The other one is single deployment. So you will deploy, for example, in cloud, just one application, a big application, just for example, to the cloud. And then the other one are multiple deployments. So other teams can deploy already their application without knowing that they have changed and they don't already communicate with you. So that's why it's difficult also to communicate through microservice. And then the other one is one database. The other one can choose how many database they want because their microservice is different from each other. Some of them can have no SQL, some of them have relational. And then the next one is transaction. So you will be dealing just transaction within your application. And then the other one, in terms of transaction, it is called eventually consistent because there will be a network call. Having a network call can have a latency since it is evident that it will fail. Some of the one of the microservices can fail. Then the data from one microservice can is called eventually consistent, meaning uh, it has not strong consistency. Unlike in your monolithic application, if you transact commit if you commit to the database, it will be committed immediately. But in the microservices, it will have a latency first. And then the other one, scale as a single unit. So your application could also scale, but the whole application is the one that is being scaled. And then the microservice is the one scaled separately. So the services here already have independent choice on how they scale their application. Sometimes one microservice can scale because that microservice is the one being hit by many requests. Unlike for the monolithic, if one component is just being hit or one module is being hit by many requests, then still the whole application will be the one being scaled, and then owned by a single team and then owned by multiple teams. Therefore, if they are owned by different teams, they have different platforms, meaning different cloud platforms, different on premises or hybrid cloud platforms. Unlike on monolithic, most of the time it is just a VM. So it is just one platform. But if they migrate it, then yeah, just still one cloud platform. So the next one will be, so monolithic makes sense if you have simple applications. If you're just starting your application, you're just in the MVP stage, you have a small team, and then it is good for projects that is on the early stage, meaning they don't interact with large teams, unlike the microservice, which is the one fit to those. So That large team can be called distributed teams. They are in very different geolocations, so they are very hard to interact with. And microservice, it does make sense to that because there will be the one owning that specific service, and then large organizations, and then a complex application that I will be reiterating later on why a microservice should not be the first one you will create when creating a simple application. And then DevOps culture. So DevOps culture here is, so DevOps is not just a work, it is how, or the way you uh, create your system. So your application should also have your the standard, and the processes that you have should also cover your application, like you have rapid provisioning, so a cloud platform is very good for that. And then a good pipeline, for example, if you have a GitLab workflow or a GitHub workflow, then it is very useful to use that kind of technology to have a faster time to market when dealing with the DevOps culture. Next, layered architecture. So I will be showing you the most of the common architecture that most of the time some developers are not aware, but they are coding in a layered architecture. It is the usual way to create an application from scratch. If some of you are creating an application like Spring, the tutorials there are using layered architecture. It follows the technical partitioning, meaning they are partitioning the code. They are putting it in your packages in such a way that uh, very technical. So this technical will be this one. So first, for example, if you have a code for employee, the first technical characteristic will be the web or so-called controller. So if I want a payroll control, I put it already to the controller package. If I have a employee controller, I will put it already to the controller package. So most of the tutorials is like that, layered architecture. And then business logic is the service one, the persistence is the repository. So if I have a service, I put that to the service package. If I have a repository, I put that already all in the repository package. So that's the layered architecture. Now, what's the problem of that? We go back again to the big ball of mud. Since I put all of my repository to the repository package, the service to the service package, and the controller to the controller package, the employee now can call the repository of payroll even though it doesn't have a relationship to it. So I can call a package on I can call a class on that because I just put it immediately to one of the package, and I can call it because why why can't I that, because the class is already, for example, it's already public, and I'm a developer, I want to call that. So yeah, I just call that because I want a band-aid solution already to my application. I want to deploy it because my manager is already angry and I want it to stop this. So I do that. So that's why the layered architecture is susceptible to a big ball of mud. For most of the time it's for the monolithic application, and then sometimes it's in microservice also is susceptible on that because that's the way we code it in a microservice also. So let's go now to modular monolithic. It is not a replacement to microservice. As I mentioned, we are dealing with trade-off. We will not be dealing with the best architecture. We want an architecture that makes sense on our current environment. And modular monolithic is one of an approach for a simple application. without using the one with from the monolithic. So it's a stepping stone to microservice. Why? We will see later why it will be a good take before going to a full microservice. So hype cycle. So just I just saw this from Tech World with Milan, and I think he wants to see that most of the time we want an architecture that really improves our productivity. Like in the future, since we already use a domain-driven design and applied a modular monolith in our simple application, then we can convert it the way we want in the future to a microservice or a CQRS. So CQRS is also part of some of it are part to a microservice such that it is just events. So yeah, I think he is just telling that the productivity is increased, or the productivity is increased when using a modular monolith. Although I think he is just biased. So why should we avoid creating microservice first? So let's have a quote from Martin Fowler, or the famous book of the clean architecture and then the clean code principle book. So he said that you should not start a new project with microservices even if you are sure your application will be big enough to make it worthwhile. So that's why we developers want to create already functionality in our system that it is useful in the future, even if it is not important yet in the present, right? So we inject too many functions, we create many services even if it will be stuck there, and we don't know if it will be used in the future. So for microservice, for example, you just create there an API because maybe in the future that API will be useful by another team, even though there's no requirement yet for that. So from a quote from Martin Fowler, I think that makes sense on that one. Okay. So why we don't create it in the when we start our application? Because Yagni, you ain't gonna need it. So you don't need at the moment. In the future, maybe not. So just stick with the present. And then domain boundaries. So this is the one given by the modularity benefit of a modularized application. So I have some description. So build a simple structure first. Sometimes they call it KISS. Keep it simple, stupid. You just create application as simple first, and then avoid premature optimization. So the right term for that we developers creating too many functionalities even though that is not in the requirement is called a premature optimization. We are optimizing something that is not worthwhile, that is not productive, and we are just frustrated why our application is very degraded because we are also the one who made it that way. And then the other one would be the domain boundaries. Using the domain driven design is define your bounded context. So define your bounded context, communicate with the business what is the requirement that they are trying to communicate with us. So this communication requires a domain knowledge, meaning if you are in a industry of financial, most likely you will need a knowledge about financial. If you are in the industry of insurance or in the industry of telecommunication, you should have a knowledge or uh, some knowledge about the domain languages that they have. So the communication that the domain driven design is telling about is that it is not about the technical terms, it is about the business terms that they are comfortable with understanding. So we, developer, engineer, or consultant, whatever you are, or an architect, should have an understanding of a specific domain, because this is the one that you will use to communicate with them. They don't want any technical terms when communicating. And then discover your domains, discover the domains, the inherent domains within that communication that happened. So that's why you should not create first a microservice. You should check first the complexity. You should check first, is my application is decomposed enough, so that in the future, if I want to create it as a microservice, then I'm confident that I've already made my application modularized, and it will be easier for me. And for example, if you have very strict metrics, you can immediately have very good story points on this one, because you're confident now that during the phase one of your project, you already define the one that you will create as a microservice in the future. So let's go to modular monolith. Monolithic architecture that is represents its functionality based on its domain area. So uh, when we do the monolithic, we didn't specify yet about the domain-driven design. It is just a literal module that we put the code into it. But now the module that the modular monolithic is referring is, there's a purpose of it. Why is it a module? That's so called the domain area. So for example, the one earlier, the employee can be now a domain area, not just a literal package name. So this now the domain areas. Okay, so if you see, it's just like monolithic, but if you go now to the green parts, I call it now domain A, domain B, domain C, and domain D, not the module anymore. So this one has already a bounded context within it, with the right communication with the business, and then it's still a one database in a single deployment unit. So domain-based approach, the domain-based structure, and the domain-based boundary. So the first one, we will discuss the structure, group of your codes and directories as close as possible to the defined domain. So as I've said earlier, you must now group your codes. Technically, it is done by module, by using module, but you must group it, your codes and or directories files, as related as possible to the domain that you are solving. Domain-based boundary, with the help of bounded context that you have already established, we define the purpose of your code in a functional way. It is not anymore in a technical manner, but in a functional one. So in terms of, for example, for testing, you know already that this one is for the functionality, for the employee functionality, for the credits or loans functionality of the savings. So it gives you a hint on what is the classes, codes in a specific module they are in. So what is the value of modular monolithic? Um, since I've already showed what is some of the modular monolithic, what it is for me? Why should I use it? Why should I consider it or present it to my stakeholders? First is functional decomposition. So you already decompose your code, your directories, the domain in such a way that they are very functional and very near to the requirement of the business. And this is also a potential to be a microservice. It is a simple architecture. So it is still monolithic. It has the it has the characteristic of the monolithic. So it's still simple. So very easy, very the calls are method calls, no API calls yet, and it is very good for teams with a very small count of developers, maybe one, two, or less than five. It's very good to use this kind of architecture. And also, they are in the same geolocation. So communication still matters, and um, creating a monolithic type of application requires developers that are very near in each other. And time constraint. So since if you create a microservice already, and then you have a constraint on your time that you want to deploy already, so I think that is not a good one to create first. Maybe this one could help you since it will act as a microservice, but just in a single deployment unit. But if you're considering it for you are running out of time, then I think most of the time monolithic type of application is the one that should choose. And then budget constraint. So creating microservice requires money. So every API calls, there is money for that. Every deployment for microservice, there is money for that. When you make a GitLab repository, that is part of the license of your organization. So that there is money for that also. Unlike if you are creating a monolithic type of work with the functional characteristic, you just have one repository, and then there's no API call, so there's no money involved in remote interactions. And then budget constraint also is uh, can include for the count of the engineers or developers. If they are like laying off engineers or developers, I think microservice is out of option anymore. So you should go back to monolithic. Yeah, in my experience, monolithic will be the one dealing with that. So modular monolithic architectural characteristics. So given the what I said about architectural characteristics on the most of the first slides, so it this the one in the y-axis is the architectural characteristic. So let's go first to the availability, scalability, elasticity. So this one is more of a kind for microservice. So that's why it's very low on the for the modular monolithic, because it's still a monolithic type of application, and being available, it's very obvious that when the application is down, then all is down. And for the scalability, uh, it's just one application. If you scale it is not scaling the different parts of your module, but when you want to scale just one of your specific component or the module there, then you are just scaling the whole application also. So it's very low. And elasticity, and then tolerance. So for tolerance, when an application is interacting with your modular monolithic, when the modular monolithic is uh, I think it's down, and then yeah, there is no solution anymore, since it has very low for the fault tolerance. And the good part is for the maintainability, it's kind of, I think it's for me, I think it's a 50-50. It depends on the developer on how they are well trained on how to think like in a domain perspective manner. So if they are trained in a layered architecture, maybe sometimes they the practice of creating application in a layered architecture uh, will be will be used in a modular monolithic application. So kind of 50-50 on the depends on the developers. And installability called the deployment. So since the deployment is just one deployment, then unlike the microservice, you can deploy um, faster. But here, since it is a big package, sometimes it is a big artifact, then the deployment of it is very large. So I set it to 50/50 also. And then the good part is, so simplicity, cost, and modularity. Simplicity, obvious, it is a very simple to create. The cost of it is good also because you will save money out of it. You will not have that API calls or multiple repositories. And then the modularity, which is the one that it is being endorsed by this kind of architecture. This is, I think this is five, since it will really have a modularized application. So that is the architectural characteristics for the modular monolith. So practical approaches or ways to create a modular monolithic. So technical partitioning. So this is the one I'm telling about earlier. So if you put application that is repository, that has repository in its name, that you will put it immediately to your module or your package with the name repository also, and then that is also evident for service. You will put it immediately to the service, and then domain. Sometimes I think I should call this entity sometimes, and you put it immediately to that package. So they don't have yet the functional decomposition when structuring your code. So that's a thumbs down for me because my talk is about modularization. Okay. And then the domain-based structure. So apply domain-driven design. So we will now try to structure our code based on the uh, functional way in our application. So firstly, you can so most of the developers I know use a Maven, but for now I chose the Gradle, but it's still the same. Maybe the syntax are different. The syntax are different, but the purpose of it is still the same. So expose each module as an API, and then minimize visibility of implementation. If we want to implement something, it should be the abstract or the interfaces that is only can have visibility on their implementation. So this is just like, yeah, there's a folder there, the API there called the employee and the payroll, and then that is the Gradle module. That is called the Gradle modules here. So this is the Gradle module, and then they are called now the API, since they are the modules is being called by other, maybe within the project. It can be also a different project. So it's still under the Java platform, and then there's still a package, but now the package is decomposed in a functional way. So for the employee, it will have the employee service, and then employee repository, and then the payroll is have already the payroll. It could be the entity, for example, for the Spring JPA, and then the payroll service, and then the repository. So they are now inside one of the packages. They are not partitioned just like the earlier one. So let's try to see that in a project. Modular. one. So as you can see, let's try this first. So okay, let's try to see the structure. So first, yeah, this is the one I'm talking about for the Gradle. So first is the employee here. So the employee here is a sub project of a Gradle, but we will treat this as a an API within my project. Since, for example, it will be called to my main class. And then the payroll also here will be a sub-project treated as a module. So the one that I'm referring is the how it's structured now. So firstly, this is the payroll, the repository service. We already omitted the technical partitioning. So they are now a domain. So they are part of the payroll domain inside my modular project. And then that's also evident for the employee. So they are now part of the employee domain, like repository service and service employee. Okay. So there are three: employee, repository, and then service. Okay. So also, if you want to call this in a Gradle fashion, you should just could include this on your root project if you want to call this the APIs. So you may include that on your project, and then when you go, this is like the pom.xml on your Maven. So this one, yeah, you are implementing now an API. For example, the employee, the payroll. You could call now um the classes within it. Since this is still public, so all of them are public interface public. So you could call that. The one thing the one thing here is, um, this functional decomposition doesn't consider about the spring beans. So when you are decomposing this one, you are still accessing the beans. For example, this one, okay, the payroll service. I think I have the IMPL. So this one is still I think this one is still showing as a, you can access this one still as a bin because it is still public, and then it doesn't consider the modularization for the spring bins. We are just in for the Gradle multi-module approach. We are just considering it for how the visibility of each classes. So for example, if the payroll service here is in default package, then I'm very sure that this one will not be any more access to other application. Even if I call this one to, so for example, I think this one payroll. So just the payroll service, because payroll service is the one that is public, and I'm sure that my implementation, so that's the one of for the modular monolithic, the implementations is hidden to its respective colors. So I'm pretty sure that I'm just calling the payroll service. So that is one for the Gradle multi-modular approach. You are just removing using the basic visibility access modifiers of Java. So but when you structure it, it looks like this. So, for example, this internal, it is a technical term for modularization. They want to put something that in the internal package, they want to put something there that is not visible to the other callers or the other consumers. So, but this one will be solved by another technology called Spring Modulate. So, Spring Modulate later on, we will see how it shows the beans now it will now consider the beans, the spring beans, not just the the access modifiers. Okay. So okay, let's go back again to the slide. Mhm. Slide. Okay, share. Okay. Next one. So how do I verify modular structure using the Gradle build, Gradle multi-module earlier? So as an architect, as a developer also, you can do this. You can have a automated test for structuring your code. So for example, if new developer wants to inject some codes already and you want to verify that it's still conforming to the modular monolithic architecture style, then there's a, I think some of you already know, but let's see, the Arc unit. So the Arc unit is a free technology, free library in the internet. It's also have a GitHub page. So it analyze your packages, your classes, uh, based on the rule that you are going to make. So this rule, we could make a modular monolithic rule using a Arc unit. So let's try to GitHub. Okay, I'm gonna stop and show the GitHub one. Okay, so this kind of library is, yeah, you can call this to your application, and then there's so-called rule that, for example, if this package is, if the class is inside this package, then it will succeed the test. But if you are restricting that kind of class to a specific package, then it will fail the test. So this is good for verifying that your application is still conforming, for example, for the modular monolithic. And then let's go back to the IntelliJ. And then modular Gradle. So let's go now to the test. Okay. So some example of verifying the employee domain. So I will verify that the import package is the base import package that I will be verifying is the form.rjt mahinay. This is my application, or this is called the API package. And then I have a rule here that states that the classes inside my domain, this form.rjtmahinay.employee, should have a classes that have starting with the employee. So let's try to run this. Okay, I think that's good. Yeah, it's verified that the classes in the have the employee classes, or the employee, all of the classes are in the name of employee inside the employee package. But let's try, I will do this. Sure, continue. Okay, and then let's try to test it. How's it starting with employee? Where is that payroll repository? Okay. Payroll. Okay, let's try go this first. Payroll. Okay. Let's try if we put some of the other non-related classes. Okay. I think we have. I think we should have a different rule for that. Okay, let's try to have so art that have starting with the shoulder side. Okay. Uh, let's try creating another rule. Just verify other employee, other domain, non-employee domain. And then shoulder side should should not no classes that starts with payroll. Payroll should reside in a package. Let's see if this will succeed. I hope this succeed because we put a payroll. So what's that? Reside in no classes that's name started with payroll. Okay, she was violated two times. Oh, okay. So it failed. I think I was confused. So since I put a rule that the payroll should have the payroll should not be in the package of employee, the domain employee. So it was violated two times. So let's get this back to here. Since my test failed, and then try to have okay. So it already works. So this is a simple way to have your application match the domain-driven design. You could have a custom rule to have a such that the classes here should match for the prescribed package here, and then also for the employee. So in this demo, we are dealing more of the testing part. So just checking the architectural aspect of your application. And this kind of test, although this is just used by the architects for their automated testing, you could also use this in your maybe you can propose this to your organization, an automated test to have to check the your application for the domain driven design. So yeah, that's for the Gradle demonstration. So it's up to you if what kind of rule that you have. So there are so many rules for this one. It also have rules for fields and members, like it's checking the fields that must be in place inside the class, and the members here is called the getters and setters, or the methods also. So it is checking the methods and the fields that are allowed to a specific class. So yeah, and then okay. So that's all for the Arc unit. You could explore Arc unit in your free time. So if you want to create your own domain-driven design application. Okay, stop sharing. Okay. Share screen. Okay, so we explored Arc unit and how to create a simple test for this one. I've also check out the GitHub for that, since it's very rich for the for your application, very rich API to consider for developing a unit test for an architecture in our application. Demo. Okay, so the next one is a Spring Modulate. So this is a new way to structure your code in a Spring Boot. So we will be focusing now on Spring Boot applications, and then it will be focusing on the Spring Beans as a module, and then it will have a verification, integration testing, and on how to create a documentation. So it will create, I think, when I last used it, it will create a plant UML on this one. So check out the Spring Modulate documentation. We could see this one. Share screen. Yeah, this one. So Spring Modulate, create an application, and then so the one that I've said earlier, you can create a plant UML kind of uh, a file. So it will create a file, and it will be in the document, a target folder. And then you could also test your application for the structure for this one. So let's try to have a demo for this one. Okay, later. I have still slide. Let's go back. Window PowerPoint. So how Spring Modulate works, aside from the Gradle module, which considers only the access modifiers of each of the classes, and then using arc unit, you will test it so that the respective classes are in the right package. So what is different in Spring Modulate is that it is now trying to map the module here, which is a Spring Bean, to a specific uh, package. So the the package here, the module here will be converted to a package, and then it will consider that as a Spring Bean. So the convention here for the Spring module is that it is still the same. You will have the domain. It is now inside one application, and then there's still the employee, the service, the repository, and then the payroll service and repository. But if you can see this one, this will act now as a bin. So if one is calling the payroll service from the employee service, it will call now. It will auto wire now as a bin. So not just creating an object. And then if you are putting the class inside the internal, the Spring Modulate uh, said that it should be forbidden, because this internal, this one will have the implementation. So we will not expose this to the consumers in demo. Spring Monolithic. Share present to audience. Modular Monolithic. Okay, so this is still a Spring project, but I will now be using a Spring Modulate. So uh, this is a project under the Spring framework. You can call this one. This is already at version 1.0.0, but now I think this is now at 1.1. So we will try to see what it is doing when using the domain driven design. So I have still the employee. They are now in one folder in the source main Java immediately, and then they are still acting as a bin. And then this is a test, and then let's see how this test will we will see what will be the output on this one. So I think I print the modules. Okay, so by using the Spring modulate, its logical name is the employee, meaning it's now your domain. And then, unlike the Arc unit, this one is structured so that you can see the relationship of the bins. And then base package, employee, direct module dependencies, non-Spring beans. Yeah, it's considering down the Spring beans. And then the payroll, which has a Spring bin of payroll repository. So let's try to call some here. What if I call employee? So employee direct module Spring beans. Okay. What if I using required args constructor? So I'm using guys logbook. So logbook here is uh, kind of a tool so that you will not anymore create getter or setters or the constructors and their dependencies. So if you see here, I'm already will be having a constructor here immediately. So private final, I will call, let's see, payroll repository. And then if we see the structure, so yeah, this will have already a constructor within it. And then let's let me try to run again the test to see what will be the output. Let's see. Okay, you have now a direct module dependencies on payroll. Okay. So now, a while ago, it doesn't have a direct module dependencies of payroll, but now uh, it has already because we call one of our bins using the payroll repository. So if we want this to be hidden or violate, let's try to create an internal here. And let's see what payroll repository. And then let's see employee service, till the repository, and then verify. Let's see, verify contains detect violations. Okay, let's try this first. Oh, no. So module employee depends on non-exposed type, a repository with module payroll. So now, when we use arc unit, we are the one explicitly uh, create a rule for that. But for this one, we just created an internal, so meaning I don't want to expose this to other module, and I want to be hidden it because the employee doesn't have really a relationship by calling that repository. So I want it to be hidden. I want this one to be just called by the service. So I made it hidden, and then when I start my verification of my module, yeah, this is the output. So this Spring module it is a good tool for you to detect your modular monolithic application, not just for testing, but if you create applications already modular monolithic, this can be a good start because you can already that unlike from the Gradle multi-modular, you will create different modules, and then the build time for that will increase because you will have different build that Gradle for that one. So this one just one project, unlike when creating the multi-modular in Gradle, you will have two more projects here, like the employee and the payroll. But this one, we can leverage now by hiding the implementations. So I don't want to be this one to be seen to other application. So we will just create just another um, a package called internal, and definitely it will have a violation when you do all your testing. Okay. So that is one of way to create a modular monolithic application. So it's very easy to create modular monolithic application. The very thing first that you create first is understand first the bounded context, the domain, the problem, and then the technical part will be very easy because it is just one application, and then most of the developers I think are already upskilled using Spring. So yeah, I think this is good. So I'll stop sharing, and then I'll continue my slide. Okay, so we have already 1 hour and 33 minutes consumed. So will you consider modular monoliths in your projects? That is my question to you. I hope after this session you will reflect if when you create your application first, it will fit on your requirement and it will help you to have a more functional decomposition before going to a fully microservice. And then summary, so we tackle the problem without modularity, the two extreme cases, the big ball of mud and the distributed big ball of mud. And then we discuss the modularization. And by modularization, we use the domain-driven approach. We tackled also the comparison of monolith and microservice and the relationship of modular monolithic to a simple monolith one. So most of the characteristic of modular monolithic is monolith. And the last one, we explored two cases on how to create one, a simple one. First is the Gradle multi-modular approach, which is you need an arc unit in your unit test to see really if it will it will match the modular monolithic architecture. And then the Spring Modulate, which is a new technology that we can explore more if you have free time. Because explore it more since it considers now the Spring Beans, not just the access modifiers being taken out, but also the Spring Beans. And then for my references, the three books and then some of the famous Java conference speakers, which they deep dive on modular monolith. And then, yeah, for the Q&A, let's go for the Q&A.
Okay, thank you so much, Tristan, for your presentation. Everyone, let's give our appreciation to Tristan by clicking emojis. Ayun. Now, moving on to our question and answer portion, we have here our first question from Ryanel. This looks great, although everything has its trade-off. Can you share at least one trade-off this implementation?
Okay, so this trade-off, I think, is the one if this one is not very, if the developers making it is not a very good on decomposing a domain, I think that is one of the trade-off that uh, you will consider. And the impact of that is the performance of your application, since the architect one of the architectural characteristics is performance, and if one is not very keen on the domain, I think you will experience very poor performance in your application, maybe in the future. Yeah, thank you for that question, Ryanel.
Okay, great. We also have another question from Dex. What are the most significant advantages and drawbacks of implementing a modular monolithic architecture in Java compared to traditional monolithic or microservices architecture?
Okay, so we go first to the most significant advantages. So when comparing to a traditional monolithic, very obvious, doesn't consider how we decompose things, or how we decompose the functional perspective of your business. So monolithic architecture way back then was just create a SOA type of application, and then yeah, put it in production. So most of the architectures back then were using service oriented architecture, and most of it are not really considering the domain driven perspective when it comes creating an application. And for the drawbacks here is that still a monolithic, so one of the architectural characteristic that will be impacted is the availability, since we are now in the cloud platform era. So I think the modular monolithic is just very good for a starting project or MVPs or phase one projects, because it will impact your scalability, also your availability. Unlike the microservices, it already have the advantage in terms of the scalability, availability, and elasticity. Yep. Thank you, Dex.
Thank you for that. And we also have another question from Kim. Can you share a specific scenario or industry where modular monolithic has demonstrated a clear advantage over microservices in terms of development efficiency or cost effectiveness?
So one of the industry, I think, is for the corporate technologies. This is called the back-end applications that is not very consumer facing. So you will just create applications just for your internal organization that is not very keen to the availability, the scalability of your application. So this is very good for creating just a simple application for them that is not gonna handle many requests or gonna send out many response to consumers. Yeah. And also I think yeah, I think that's a very good example. Yeah, the corporate technologies.
Great. And we also have another question from JC. How do we mitigate duplicate codes across different modules such as similar functions and or models?
For duplicating a code, for example, for the Gradle multi-modular approach, the best way is to just create another module for that. So just consider the common code as another domain, or so called it an infrastructure domain. So infrastructure domain, technically speaking, is it is just a domain that is will support your core domains. So core domains are like the one that I showed earlier, the employee, the payroll, and the infrastructure domain will be just the one will be supporting, so that it will be the just the placement of your similar or common codes and models. So yeah, that's the answer. Just create an infrastructure domain.
Okay, I hope that answered your question, JC. And we also have another question from Ronaldo. Modular monolithic sounds to me like a rebranded service oriented architecture, SOA. What is the difference?
I think the difference is that the SOA is giving us the impression of using a technology called the enterprise service bus. So for the modular monolithic application, it doesn't really need a application integration application or the middleware. You can still use modular monolithic in your cloud platform immediately, deploy it just like a service, like a microservice. But for the service-oriented architecture, I think the key difference is that it really needs a middleware for that. Yeah.
All right. We also have another question from Mar. Should all projects start as monolithic?
Okay. This is well, by default, I suggest that all projects should start a monolithic, so that you can have, or you can see the complexity within your specific domain. But there are times that your organization is very matured already. It's matured, your team is matured, you are a team on different geolocation is matured already, and uh, your organization can start microservice already without doing a monolithic type of work. So that is I think most of it just a wishful thinking. But if that's the case, that your organization has this good process, your pipeline is good, you have rapid provisioning, you have a very good DevOps culture, then I suggest that you move quickly to microservice. But most of the organization is having struggles when dealing with DevOps culture. So that's why creating in monolithic application is a very good start.
All right. And another question from Analo. How does modular monolithic be applied in our day-to-day life?
So modular monolithic can be applied to your life. Let's go back to the way we think on domain-driven design. I think that's the significant part of modular monolithic. When we see things in a business perspective, in a requirement perspective, we will see that it's easier now to create systems because we already know what we are doing. When we practice that kind of thinking, we can share this to our team, yeah, and then yeah, just practice it. So this is more like of improvement of the way we think things when creating a system, not just not just going to technical immediately.
Okay. And for our last question from Nino, how to maintain the balance between comprehensive testing and efficient test execution in consideration of compare and contrast the testing approaches used for modular monolithic applications and especially to those used for microservices.
Okay. Maintain the balance between comprehensive testing and efficient testing executions used for modular monolithic application. So to maintain balance, I think this is more of the process. of the way you do in your organization. I think modular monolithic could impact since it is still a monolithic type of work. Yeah, there will be struggles that your testing will still, your integration testing will still test most of the parts here, but the good thing here is you, in a functional perspective way, you are now, you know what you are going to test, just like how you test in your microservice that specific domain. So when you deploy something in a modular monolithic, and then you test it, you know what is your target. So yeah, this is more of like the tester type of approach. Just
Okay,
focus on the
again.
functional. Yeah.
Okay, again, thank you, Tristan, for your presentation. And to our audience, in case you guys have any questions to Tristan and our other speakers, you may engage with them through our Ermit Lounge. You can ask them questions. And before letting you go, Tristan, can I ask for a quick photo op?
Sure, sure.
Okay, one, two, three. Smile. Thank you. Okay, thank you very much. So again, thank you, Tristan, and we have a lot of emojis for your presentation. Thank you for that. And for a few reminders to our audiences, before I let you go, guys, did you know that we have a leaderboard? Click the trophy icon at the top right of Ermi to see who's leading. Who wants to win an Alexa Echo from PSIA? Well, you better start tracking up points. We also have prizes for the top 10 from Globe Business and IBM. So, how do you earn points and dislodge our current top 3 leaders? Update your profile, ask questions, answer polls, click emojis, visit the virtual booths, visit sponsors' links, and more. In other words, please engage to our meet. This will continue until tomorrow. So, we have plenty of times to earn points. We will announce the winners tomorrow late afternoon. And if you have a hybrid ticket, please download the Airmeet app from the App Store or Google Play so you can continue engaging on the app even while you're at SMX tomorrow. And our registration opens at 7:30 a.m. at SMX Aura. And for virtual ticket holders, live streaming starts at 8:30 a.m. See you tomorrow. That's all the time we have for this session. Thank you. You may now exit this session and go on to the next. Bye everyone. See you at SMX.